Okay, now welcome back. And now what we're going to do is we're going to do some examples of using linear approximation to estimate real values. Okay, so in this case, we're going to use the function of x squared. Okay, and what we're going to do is we're going to use this function at x equals 9. We're going to form a linearization of this function at x equals 9, so that way we can then use that linear approximation, that linearization, in other words, to estimate the value of the square root of 9.1, which is not a perfect square. 9 is a perfect square. 9.1 is not a perfect square, but we're going to use, or excuse me, the square root of 9 is, but we're going to use this fact that, hey, since it's very close to a perfect square, we're going to use the fact, that fact to estimate what the square root of 9.1 is going to be. So let's get started. Okay, so again, what do we need to do? So this is our a, this is our function, so we're going to approximate it, so f of x, right? So we're going to approximate it is approximately equal to what? It's going to be f of a plus f prime of a times x minus a. Okay, so now I'm going to fill in the information. F of a, so this is going to be approximately equal to f of a, which is going to be what? 9. So it's going to be the square root of 9 plus, what's this? This is the derivative. Well, what's the derivative of square root of x? Well, that's going to be 1 over 2 times the square root of x, but x is equal to 9, right? F of a, right? So it's going to be 9, right? Because it's f prime of a, so f prime of x is 1 over 2 times the square root of x. So we're going to plug in a, and now we get x minus 9. Okay, so now let's simplify this. So this is going to be approximately equal to 3 plus 1 over 6 times x minus 9. Okay, so now there's our linear approximation. Okay? So now we're going to approximate this for 9.1. So what we're going to do is now we're going to find f of 9.1. So now it's easy, right? Because now all we're going to just do is plug in 9.1. So it's 3 plus 1/6, and this is going to be 9.1 minus 9. Okay? And so this is going to be approximately equal to 3 plus 1/6 times 0.1, which is equal to 3 plus, well, this is 1/10, so it's going to be 1/60th, right? Which is going to be 180 over 60 plus 1 over 60, right? Which is then going to give us 181 over 60. And so that's the approximation. So we would say that f of 9.1, which is equal to the square root of 9.1, is approximately equal to 181.60. Now, do they give us any decimal places? Let's see. Oh, I think they do. Let me see. They don't. But let's approximate it out to 4 decimal places. Okay. So here's our answer. This is the exact approximation given. But let's approximate this out to 4 decimal places. So let me get my calculator. And so we'll just do 181 divided by 60. So it's going to be slightly more than 3. So So we got 181 divided by 60. So I get 3.0, so 4 decimal places. So it'd be 0167. 0167. Okay, so now, what is the real approximate? Okay, so let's take this square root. So now let me get my calculator. And I'm going to take the square root of 9.1. So 9. Oops. And I get 3.0166. So it's accurate up to 3 decimal places. Not bad. So it's accurate out to the thousandths place. So this is not a bad approximation at all. Now here's the thing. It may seem odd to use a linear approximation to estimate something that we can just stick in our calculator and push some buttons and get a much accurate value, okay? But here's the point. Here's the thing. Guess what? Your calculator uses linear approximations to get this answer. It just does it much more accurately, okay? So just be aware of that. Okay? So in fact, calculators and computers use approximations all the time to evaluate mathematical expressions. They just use higher degree approximations. That's all you have to realize. Okay? By the way, you want to know something really cool? Think about this. Think about your GPS system in your car or on your phone. Okay? Those are satellites that are hovering thousands and thousands of miles above the Earth. Okay? They use linear approximations to get an idea, to calculate where your vehicle is or where your phone is located on the Earth. And it's very, very high accuracy. Okay? Even though they may be off by a slightly small degree, it's actually very, very accurate. Okay? So keep that in mind. So it's used in all kinds of applications. Okay? Have a good day.